Hello everyone, welcome back. If you are new to this channel, please consider subscribing for future computer science and software engineering videos. So in this video, we're going to talk about how to delete an item or a node from the end of the linked list. In the previous video, we saw how to delete a node from the beginning of the linked list. Before starting this video, let's analyze the time complexity of delete from beginning function. So this is empty function, it takes constant time. This overall expression takes constant time, constant time, constant time. All these expressions take constant time. We don't have a loop inside this function, so the overall time complexity of delete from beginning function is going to be constant, or big O of 1. We also in the previous video forgot, after deleting an item, we need to decrement the size of linked list, or this dot len minus minus. So now let's talk how we can delete an item from the end of the linked list. Although we have a pointer to the end of the linked list, we cannot delete this node using this tail pointer because it is a singly linked list. In order to delete this node, we need a pointer or a reference to the second last node, and also since in the linked list we have only one or unidirectional traverse, we cannot go backward to access this second last node. So to do that, what we are going to do, we are going to start looping from start of the linked list and go all the way up to the second last of the linked list. Once we got a pointer to the second last, let's call it temp or previous. Then using this temp pointer, we can set this pointer or this node's next pointer to null. Then we will detach this connection, and this node is going to be eligible for garbage collection and it will be deleted automatically. So to do that, there are basically different ways. In this video, we are going to mainly discuss 3 ways to delete an item from the end of the linked list. You guys can choose whichever method you want. So the first method is to maintain 2 pointers and check until we have not reached end of the linked list. So I'm going to maintain 2 pointers, temp showing the current node for traversing over the linked list. This is going to initially point to head. Then I will also maintain a previous pointer initially pointing to null. Each time I traverse over the linked list, so before updating the temp pointer to the next node, I will have the previous pointer first point to the temp, then I will update the temp pointer to the next node here. In the second round of loop, before I update or jump the temp pointer to the right, I will have previous pointer first point to the temp, then I will make the temp pointer point to the next node. So using a while loop, we can do that. We saw in the previous video. So let's write a while loop. While temp dot next not equal to null, until any node whose next pointer is not pointing to null, we keep looping. Once we reach to a node where its next is pointing to null, we have reached end of the list and we exit out of the loop. So inside the while loop, what I do is I will first set the previous pointer point to temp, or the current node prev equal to temp. Then I will increment the temp pointer, temp equal to temp dot next. So this way I can maintain 2 variables. Once I reach end of the linked list, so once the condition, if I reach this, if temp point to this node, so I check if temp.next, which is this pointer, not equal to null. Yes, temp.next is null, we exit out of the loop. I will also have another pointer previous here. So using this previous pointer, we can easily delete this node. So I can say previous or prev.next equal to null. So we detach this connection, and this node is going to be eligible for garbage collection. We should also update the tail pointer and make it point to the second last node instead of pointing to the last node. So we can do by just setting tail equal to the previous or the prev node. So this is one way to delete a node from the end of the linked list. So let's write the code for this algorithm. Public void delete from end. So there are also 2 corner cases. First we check if the list is empty, we just return, and also we check if the list has only one node, then we set both head node and tail node point to null. So let us take care of our corner cases. If is empty, this is empty, returns true if the list is empty, otherwise it will return false. A list is empty and return. Else we check if there is only one node in the linked list. We can do it by if if this dot len equal to 1, or if head dot next equal to null. If there is only one node, we just set this dot equal to this dot head equal to null, also this dot tail equal to null. Next we are going to maintain two pointers, previous pointer and temp pointer, node prev equal to null, also node temp equal to head. Using a while loop, we check while we haven't reached end of the linked list, while temp dot next not equal to null, we just update the previous pointer first, prev equal to temp, then temp equal to temp dot next. Once we got a pointer to previous node or the second last node in the linked list, using this second last node, we can easily delete the last node. So first we are going to update our tail pointer, this dot tail equal to previous or the second last node, then we say previous dot next equal to null. So we are also going to update our len variable, len minus minus, if we have one if head equal to null. If we have only one node, and we say len minus minus, and we return in this if statement. We don't want to calculate the rest of the statements. So let's check our function here. I have 10, 20, 30, 40, 50 list dot delete from end. So 50 should be gone. 50 is gone. If I want to, after deleting 50, if I want to insert at the end, let's check that also. Insert at end, say I want to insert number 100. This should be our last node. Yes, 100 is inserted and the size of the list is 5. Okay. Next method, we can delete the last node using only a single pointer. What we are going to do, we take a counter starting from 1 or first node and go all the way to len minus 1 or second last node. Once we got a pointer to the second last node, we can easily delete that. So let's do that. Go to this program. So I'm going to comment out these lines of codes. We don't need two pointers, we just need only one pointer. We just need only, let's use temp to traverse over the linked list. We don't need this also. So I'm going to traverse over the list up to the second last node. So for that I will maintain a counter equal to 1, initially indicating the first node. So while counter less than this dot len minus 1, we give it minus 1 because we want to traverse over up to the second last node of the linked list. We just say temp equal to temp dot next. Once we reach second last of the second last node of the linked list, temp pointer is pointing to the second last, so this, we will say this dot tail equal to temp, then temp dot next equal to null. This is the second method of deleting an item from the end of the linked list. Let's run our program. Temp equal to okay, we need to increment our counter here. We forgot to increment our counter plus plus. Number 50 is gone, so let's add an item. After we delete that, let's add 100. 100 is inserted. The third method of deleting the last item or the last node in a linked list is again going to be using a single pointer. to maintain or obtain this reference variable using the previous pointer, we can access the previous pointer dot next, which points to this node, then this node's dot next, which points to this reference variable. We check if this reference variable points to null or not. So we can say we can maintain a temp pointer saying temp equal to temp initially equal to head. Then we check while temp dot next, which is the next node, not equal to null. We keep moving. Okay, if head temp is equal to head, then temp dot next, which is this node, dot next, which is this reference variable, we check if this is not equal to null. No, it's not equal to null. We continue looping. Then once our temp pointer comes to the second node, we say temp dot next, which is this node, dot next, which is this pointer, not equal to null. No, this is not equal to null. Once we come here at the second last node, we check temp dot next, again dot next, which is this reference variable, not equal to null. Yes, this is equal to null. We exit out of the loop, and our temp pointer is at the second last of the node which we want to have. So using this temp variable or temp pointer, we can easily delete this last node. So let's do that. Again, I'm gonna comment out these lines of codes. So we are going to maintain only one temp pointer. So I check while temp dot next, which is going to give us the next node, dot next, which gives us the next node's next pointer, not equal to null. So this way we keep looping, temp equal to temp dot next. Once we got a pointer to the second last node, we again say this dot tail equal to temp and temp dot next equal to null. This is going to free the next node, the last node, and it's going to break this connection, and this node is not referenced by any pointers. This is eligible for garbage collection. This way we also decrease the length of the list. So let's test our this function also. Okay, 50 is gone, and we inserted number 100 at the end of the linked list. Thank you guys for watching. Please don't forget to subscribe, and see you in the next video. Bye bye.